Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So in the last special video request, I critiqued this page, which was one of the main topics of the video. And I showed you what was wrong with it. And now today I'll show you very briefly what the right way of doing things is. So dx doesn't mean a little bit of x or a little bit of this or anything else. What was happening here was that Leibniz was trying to formulate a rigorous calculus, okay? It's obvious to me that he failed, but not so much to others. Had either Leibniz or Newton known about my historic geometric theorem, which is the identity from the theorem, which is what you see in front of you here, none of this confusion would have happened, because this identity is as simple as 2 is equal to 1 plus 1. So there wouldn't have been a refutation by Berkeley, and of course the derivative could easily be derived from that as the difference between the non-parallel secant line slope and the slope difference, or by finding the non-secant parallel line slope in terms of x and h, and then selecting only the terms that do not contain h in them. That would be the derivative. And also the integral is also derived from this historic geometric theorem or identity, and it's simply the left-hand side, f of x plus h minus f of x, which is equal to the product of the interval width and the arithmetic mean of the ordinates plus that slope difference. So that would be the correct way of doing it. Now, another thing is that in the new calculus, a derivative is stated 100% correctly like that. There is no need to go back to a historic identity, because this q of xmn is the slope difference, and it's always 0. And it forms something very useful known as the auxiliary equation. So the integral is also stated from this identity. It's just simply this equal to the product of the two arithmetic means, the slope interval and the mean of the y-ordinates in that interval. More formally, it would be written as the sum of the, or the arithmetic mean of the sum of the intervals, of the interval means. Okay, so it would be equal to that. And of course, this f prime of mu s is simply the derivative, the new calculus derivative, stated correctly. And each one of these would basically form the partitions, the mean of the partitions in the new calculus. So from the new calculus, we have an equivalence to the mainstream calculus, which you see in this equation here, okay? So, and of course you have to do a lot of studying to understand that, but once you get past that, everything is crystal clear. Now, because most of you are not members, you won't be getting to see my critique on the rest of it, which is what you see in front of you on different degrees of smallness. And from there to there, on relative growings, etc., etc., etc. Okay, so I might be doing critiques on those, and if I do, it will only be for members. So that's pretty much it. If you're not already a member, subscribe. Follow me on academia.edu to have access to all the special requests and knowledge I haven't shared before. You'll need to become a members only, and you can do that by going to any of my videos and clicking on join, or going to this link here, okay, this link here, and then what will come up is this, and you can join by clicking this button here. Okay, it's only €5 a month, and you all know the drill by now, those of you who are watching. I'm John Gabriel. This is New Calculus Channel. Till next time, goodbye.